Good morning, everyone. Welcome back to A Factor Academy. Today, we're looking at mechanics and properties of matter. Mechanics and properties of matter. A Factor Academy. You're welcome. So, in our solution series, we're solving question number 3. Question number 3 says a block of mass 0.2 kg starts up an inclined plane of 30 degrees to the horizontal with a velocity of 12 meters per second. Now, if the coefficient of sliding friction is given as 0.16, I determine how far up the plane the block travels before stopping. Then we have to determine if the block returns, that what is its speed when it gets to the bottom of the plane. So I'll give you a few minutes to look at this question critically, see if you can solve this, okay? Now, you're given the coefficient of sliding friction to be 0.16. In this question, we are determining how far up the plane the block traveled before stopping. So look at this question very well. Then, in the next slide, we look at the solution to this. Now, solution to problem 3. Now, the first thing we are told is that what? We are told that the block is what? On the horizontal plane, right? The block is on the horizontal plane. And we have the plane is now what? Inclined at an angle of what? Angle of 30 degrees to the horizontal. Okay? So this is the block. This is the coefficient of friction on the plane. So this is the block, and the block is of mass 0.2 kg. So that means the weight of the block we add downward. So we can determine the mass, the weight we add downward. So we can determine the weight. So using the formula W, which is the weight equals to what? The mass times acceleration to gravity. Now the mass is what? 0.2 kg times 9.8 meters per second squared, which is what we are using here as what? Acceleration to gravity. So we are using our G, okay, to be equals to what? To be equals to 9.8 instead of what? Instead of using 10 meters per second squared. So we are using 9.8 instead of 10. Okay? Instead of 10, we are using 9.8. So here we're going to multiply the mass of the body 0.2 by what? 9.8 to get 1.96 Newton, which is now the weight of the body. So here we are using G to be equals to 9.8. So let's take this out. Now, the next thing we have here is what? When the body moves this way, okay, the weight will be resolved because it's a force. So now that the body is now inclined, so that means the weight will have two components. So weight of an object on an inclined plane, we have component because the weight is acting downward definitely, but the block now moves instead of it to move down. Okay, but the block cannot move through the plane because it's a plane. Okay, so it will have to slide down through the what? Through the angle at which the what? The plane is inclined. So definitely the weight will now have two components. So one will be the one that will slide the body down, and one will be the one that will make it to what? To the main of the plane. So the first component is what? The first component I'm drawing here is the vertical component, which is what? W sub what? W sub y. And the second component is what? The horizontal component, which is what? W sub x. And there will be a force that will oppose what? The vertical component of the weight, which is what? The normal reaction, which is a force that is perpendicular to the plane. Okay? So the force that the plane exerts on the block, perpendicular to the plane, and also parallel in opposite direction to the what? To the vertical component of the weight of the body on the plane. Now, next thing we are going to be doing here is that we are told the block move up the plane. Okay? Now, with the force applied, of what? Of F sub A. You don't know what that is. So this is the acceleration of the body. The two arrow here gives the acceleration. This is the acceleration of the body up the plane. Because of this, the body will have an applied force of A. So this is the acceleration. So because of the acceleration up the plane, the body will have an applied force of F sub A. So now, can you see? So the block moves up the plane, its acceleration is negative, of course, it's moving up. Thus, the body decelerates up the planes. So, and as it's moving up the plane, what happens? There'll be another force by this line that is what? That's going to be acting against the force applied, and that's what? Frictional force, F sub F. So, what's the next thing we do? So, this is the interpretation of the question. This is the interpretation of the question. Now, let's see. But you have to recall certain things from the laws of solid friction, that solid friction depends on normal reaction. Okay, so that solid friction F sub F equals to what? Coefficient of friction times normal reaction. This is coefficient of friction. Okay, here is the coefficient of friction. It could either be mu sub k, which is coefficient of what? Kinetic friction, or mu sub s, which is coefficient of static or limiting friction. So we have this. So this is the first thing you have to note. So f sub f equals to what? F sub f equals to, that positional force equals to what? Mu n. Now the next thing is what? From what we have here, force applied is equals to what? F sub f plus w sub x. How? Now this is the force applied, F sub e. Okay, and here is what? W sub x, which is what? An horizontal component of what? Of the weight. So it's moving this way, it's acting down, and here is what? Frictional force. Okay, also what? Horizontal component. Okay, acting down, and here is what? A force due to the what? Due to the acceleration a is acting up. So we're moving in the opposite direction. So total horizontal force acting on this body is equals to what? Equals to 0. So that means force in one direction because what? Force in another direction. So F sub A equals what? F sub F plus W sub X. Okay, and that's why we have this. Okay, so F sub A equals to F sub X times W sub what? Times W sub X. All right, so let's continue. Now, the next thing we want to talk about is that we want to look at the frictional force, making the frictional force the subject. So if F sub A equals to F sub F plus W sub X, that means frictional force, therefore frictional force equals what? Force applied minus what? W sub X. So let's make that equation 2. All right. Now, here we have F sub F equals to what? Mu n, right? So let's substitute, next thing, let's substitute n, okay? Okay, before we do that, let's look at what n is. Look at this, the vertical component. Okay, the vertical component, you have only n and w sub y. So, and both of them are acting in opposite direction. So this one is moving down, while this one is acting up. So summation of all vertical components. Okay, summation of all vertical components is also going to be equal to 0, right? Like I did for horizontal components. So also I did this for horizontal components. Summation of all horizontal components is also going to be equal to 0. Remember from equilibrium. So we have this because the body is on the plane. So at any point, any given point, this is going to be valid. Very good. So now n equals to what? W sub y. Okay. So that means what do we have? Okay, we know that what n equals to w cos theta from a previous series. You can watch the previous series very well. I explained how we got n to be equals to, got this to be equals to w, okay, cos theta. I explained how this is w cos theta and how this is equals to what? W sine theta. And the theta there is what? Is 30 degrees. Okay, I explained that. Now, if n equals to w sub y, okay, that is n here equals to this, then that means that what? That means that n equals to what? W cos theta, because w sub y is w cos theta. All right, so the next thing is what? We have to put these two, okay, this particular one, okay, putting 2 and 3 into 1, and this into what? Into the first equation, because we have gotten our n here, and we have gotten our f sub f here. So let's put these two into this. Okay, let's clean up the page to make it look better. Now let's put this. Let's do this. That is by putting this, okay, 3 into 1, okay, and also 2 into 1. Okay, so what do we have? We have this. We have this. Okay, because f sub f is what? This, and n is what? N is w cos theta. So we have, okay, which is this. Okay, so we have this. The next thing, we have f sub a minus w sub x equals to mu times w sub y. And f sub a, the force applied, okay, force applied is what? Force applied on this body, which is the resultant force. This is the resultant force taking the body up, okay. Of course, it's not giving, but you are giving, the body is accelerating. So that means the resultant force is equals to what? This, okay, minus w sub x, okay. Is that clear? So which is going to be equals to what? Mu, okay, mu times, the resultant force is going to be f sub f plus this at a given point when the force is balanced on the body. So satisfying this condition, okay, I put here that is putting 2 into 3, put 2 and 3 into 1. So we have f sub a minus w sub x equals to what? Mu times w sub y. Okay. So what is f sub a? F sub a will equals to what? Mass of the body, okay, mass of this body, okay, times the acceleration of the body, which is this, times the acceleration of the body. That's the force that take the body up the plane, okay. And w sub x, of course, is what? Is w sine, okay, sine theta. And w sine theta, don't forget, that's going to be mg sine theta, okay. And mu is given, okay, in the question, and w sub y is mg cos theta. Very good. So the next thing we are doing now, divide all through by m. Okay, we have a to be equals to, we have this to be written as, this. So dividing all through by m, so m called this, okay, divide through by m here, call this, m here, call this, and all of this over m. This m here called this. So what do we have? We have a minus g sine theta equals to mu times g cos theta. So the next thing after this, we are trying to get the acceleration. So make a the subject. So take this, okay, negative g sine theta to this side becomes positive. Okay, so we have become positive. Okay, this is positive g sine theta. Okay, so we have this now. And we have mu g cos theta now plus this is plus g sine theta. Okay, now after this, what do we have? We have that, okay, you put all the parameters now. G is what? G is that's acceleration to gravity is 9.8 sine theta, the angle there, which is what? This angle here, which is the angle at which the plane is rotated up, and that's what? 9.8 times sine theta, which is sine 30 degree, plus 0.16 the mu times, that's coefficient of friction there, now times 9.8 cos theta, which is 30 degree as well. So solving this, we have 4.9 plus 1.3579. Now adding this together will give us 6.2579. Okay, now which is approximately 6.26 meter per second squared, which is the acceleration of the body. Now next, to determine distance traveled, okay, by the body as it accelerates up the plane, okay, because of the force, okay. Now what do we have? Up the plane, we are going to be using, from the equation, Schubert's equation of linear motion, okay, we have v squared. You know that the body is moving up the plane, okay. So when the body go up the plane, it gets to a point, okay, of maximum point. Because according to the question, the body move up the plane to stop. So that means since the body stop up the plane, then that means the final velocity of the body becomes 0. And the initial velocity which the body move up the plane is 12 meters per second. So we are going to put this parameter into this, including our value that we get for A. in this previous calculation that we have been doing, based on how the body is what rotated on the plane, okay, to get the value for s. Okay, now let's go put the parameters into this now. Putting the parameters, we have 0 squared equals to 12 squared plus 2 open bracket minus. Now why minus? The negative here is because that's where I explain up here, because the body is moving up the plane, so we have negative. So the body decelerates up the plane. That's why we're going to include negative here. So we have minus. Instead of putting this value, you have to put negative, showing that what the body decelerates up the plane. So minus 6.26 the time, the distance now, which is displacement of the body of the plane, which is s. So to now solve this, we have take this to the other side. Okay, take this to this side. It becomes minus instead of plus. Okay, instead of plus, it becomes minus. Become minus. So taking to this side, come minus. Then 12 squared. That what? That will be equals to minus 144. Now this is minus. Okay, 2 times 6.26 s is going to give us minus 12.52 s. So to get s now, s equals to what? 144 divided by 12.52, which gives us 11.5. And that's what? Displacement of the body up the plane when it is moved up using the what acceleration of what 6 points. Displacement is body gets to, okay, which is actually like the maximum displacement the body gets to on the plane before it slide down back to the ground. So this is that. So now we've gotten s. Okay, the first thing we have to solve in the question. Now the next thing is to what? Next thing is to after getting this, let's go to the next thing. Next thing is to what? To get the value that the body will have, okay, when it's moving down the plane. So we want to get the velocity which the body will have when it moves down the plane now. Okay, so the body already got to the maximum point. Now it's moving down the plane. So since the body is moving down the plane, still inclined. Now it's now at maximum incline at 30 degrees, and this is the body, okay, with the weight acting downward as well. Okay, vertical component of the weight, the normal reaction, horizontal component of the weight. Okay, now the body is now what? Moving down. Okay, it's moving down. Now can you see the arrow pointing down? The body is decelerating. Now this time around is accelerating down the plane. Okay, very good. So since accelerating down the plane, now the force applied, can you see? Because the acceleration is to this side, so that means the applied force will go downward. Okay. Now what would be this line? This line will be representing the frictional force, because the body is moving down the plane now based on direction of A. Then that means the friction will add to oppose the force applied to make the body to move. Okay, so that will be frictional force. Now as the body moves down the plane, its acceleration is positive, thus it accelerates down the plane. So positive acceleration gives acceleration, and negative acceleration gives what? Deceleration. So if the acceleration is negative, then that means the body is decelerating. Very good. So now recall the same thing. Don't forget, we are trying to get the velocity the body will get to. Okay, after getting to maximum distance or displacement of the plane, then now slide back. Okay, so that's what we want to get now. So the first thing we need to get here is also to get the what? To get the acceleration of the body down the plane. And after this, we put it into the what? Equation of linear motion, d squared equals to u squared plus 2s to now get the final velocity. Now, but the first thing we need to do is to recall this formula, very important formula, that f of f equals to what? Mu times n. Now, after this, since the body is going down the plane, remember, the body is going down the plane. What does that mean? That means the resultant equals to what? It equals to f sub f equals to f sub a plus what? W sub x. Okay? And what does that mean? That means, let's look at it together. So let's look at the pointer, the pen. So we have the pen. Now that means this is going up, okay? And here is going down, down. So what does that mean? That means f sub f will be equals to what? It equals to f sub a plus what? W sub x. So making f sub a the subject, that means you're going to be having Now, there's a problem here, which I'm going to explain. It's going to be f sub f, as going to be f sub f minus w sub x. This is not going to be true. Now, if you do this, there'll be a problem. Even though the body is moving and we have this thing like this, there'll be a problem. And the problem is that we are not going to be saying f sub f minus f sub. It's not possible because that means the body will be moving up. No, that's not going to be correct. So what we're going to do here, in order to have a clear understanding of this, is that here we have this f sub a is not a force that is applied on the body per se because of what? Because of an external application of force on the body. Okay? It's not an external application of force on the body. So, in essence, the resultant force in this case is what we have as F sub E. So, the resultant force here is what? The force applied. And don't forget, the body moves to the maximum point on the plane and it moves down the plane on its own. So what does that mean? That means the resultant force is F sub A and it will not be equal to what? It will be equal to, now the body is moving down the plane, right? So that means you're going to be having F W sub X, okay, minus F sub F. So this is the correct version, not the previous one I did. So this one is making more sense than just saying, okay, you have F. That's one of the mistakes students make in this particular thing. The previous one by saying you're going to be having F sub A equals to F sub F minus W sub F, W sub X. No, that would be very wrong. Because if you do that, that means you are saying that what? The body moving up the plane with what? With the frictional force, which will be very wrong. So this is the best thing to do. Now, coming back to this now, we now have this now. Now, clear with our explanation, we now have F sub A to be equals to what? W sub X minus F sub F. Very good. Now, the next thing we do is what? Now, we make F sub F the subject. So that means take this to this side, okay? To this side, and we'll take this side. So what that means? That means F sub F, okay? That means F sub X minus W sub A. So this will go here, come here, and here will come here. So that means you have W sub X minus F sub A. Okay, that's equation 2. Now, but we know that N equals to W sub Y. Very good. So if N equals W sub Y, so that, of course, we know N equals to, this one is going to be equals to W cos theta. Okay, so putting 2, let me pick my pen again. Now putting this and this into 1. Okay, what do we have? We have W sub X minus F sub A equals to what? Mu times W sub Y. So that means we put this into this, okay, and we put this value, which is this, into this, which is the same thing as this, put it into that. So what do we have? We have W sub X, okay, equals to what? Mg sin theta minus Fe, which is what? Like I told you, which is going to be equals to what? This is going to be equals to the resultant force, okay, Me, okay. So that means Fe is going to be what? The resultant force, which is equals to what? Me, okay. And mu, okay, times W sub Y, okay, W sub Y, which is what? Mg, is Mg cos theta. Don't forget this. It's very important you understand how this is done. You check my second question that I solved in this series. You see I explained this in detail. So that's what W, okay, sine theta, which is the same thing as what? Instead of Mg sine theta. So this is sine theta. Okay, so we have all this. Now let's clear the screen. Okay, now we now have let's pick another thing, laser pointer. So we have this. We now understand how we got all this one. So mg sin theta minus me equals to what? Mu times mg cos theta. So dividing all through by m now. Take m here out, take m here out. Okay, do what you do to this side, which is not bad in math. Same thing. So we have g sin theta minus a equals to what? Mu times g cos theta. Now, because we have taken m out of all of it, so we are making it subject because we want to get the acceleration that is positive. We want to get it down the plane, okay, which is going to happen naturally, okay, because of the weight of the body, right? So the acceleration of the body is going to be equal to g sin theta minus mu g cos theta. So now let's put the parameters. A 9.8, don't forget. Then theta is, this is theta, the angle. This theta 30 degree. So that's theta. Now minus 0.16 times 10 times, not times 10 now, times 9.8 cos theta. So don't forget, our g is taken to be equal to what? 9.8. Very good. So to solve this, this becomes, okay, 9.8 times sin theta is going to be 9.8 times 1 over 2. We have 4.9 minus 1.3579, because 0.16 times 9.8 times cos theta, which is same thing as sin 60, which is same thing as 0.866. Okay, when you do this, you have 1.3579. So do this math. What do we have? We have 3.5421. Okay, so that means the acceleration of the body is approximately 3.54 meters per second squared. Now, you want to calculate what? Final velocity down the plane. So we want to calculate what? Final velocity v. We want to calculate the final velocity down the plane, which is what? V. Okay, we want to calculate v down the plane. So now to calculate v, we have v equals to, that's the unknown here. Can you see? This is the unknown. So u is what? 0 meter per second squared. Okay? V is actually 0 meter per second, not 0 meter per second squared. Okay, so and s is given from 1, like I said, given 11.5 meters. So what do? V squared equals to 0 squared plus, now that's 2 times a. What's our a? From what we have solved here, which is the acceleration of the body down the plane. Okay, the acceleration down the plane. Okay, which is 3.54. Then the s, okay, that we know from the previous solution in I is 11.5. So when you do this math, you have v squared to be equal to what? 1.42, which is going to give you that v equals to square root of it 1.42. So that's going to be 9.0. And that gives the final answer to the problem that we are solving.